Hello, I'm Landon Schlungen coming back to you with another video. Today we're going to learn basic JavaScript. Here I have a bunch of lessons that we're going to learn today. We are going to use Visual Studio Code for this project, or for learning JavaScript. And to get Visual Studio Code, all you have to do is, go to Google, Visual Studio Code, or just VS Code. Look that up. It's usually the first link, and then you download for Windows or whatever operating system you have. So once you get that, it should look something like this, probably with the preview bar over here, the Explorer and like extensions and stuff. To be able to run JavaScript in VS Code, I believe you have to go get Node.js as well. So if you don't have that, make sure to download Node.js. The LTS version works just fine. I guess usually when you open VS Code, it will look something like this. So color theme uh, will be default dark, I'm guessing. Either it'll be default dark or default light, one of those. Um, but yeah, then you open up your file in a folder that you're working. So here you go, file, open folder, and then for me, I'm in this JavaScript tutorial folder. Select the folder, and then it will open up VS Code for that inside that folder, and then you can start putting files in that folder. And the files we're going to be using are .js extensions. So make sure if when you do create a file, it has that .js extension on it. So here I can do in file 2 .js, and then here's another JavaScript file. But I don't really want to use this, so I'm just going to delete it. And yeah, so good. So without a further ado, let's get started. Oh, by the way, the color theme that I want to use actually is Winter's Coming. Actually, I should talk about extensions as well. I like to use Winter's Coming Dark Blue. If you probably don't have Winter's Coming available, and that's because you have to go get it at the extensions marketplace. And all it is you go to this sidebar here, or you can press Control Shift X, and then you can look up some extensions. So some of the ones I have installed are Atom 1, Dark Theme. I have Auto Rename Tag. I have some different icons. Code Spell Checker, Color Highlight, some more color themes. Go, JavaScript code snippets, some TypeScript stuff. Live Server, that's a really good one. Markdown, so that's what I'm using for this one. Or Markdown Preview Enhanced, actually. Here's another color theme. Prettier. Quokka is one that we're going to be using today. It will be able to like console log whatever we're doing in real time. So it's very helpful for this. I have rainbow brackets so that we know what brackets match up where. Some svelte stuff, tabs, winter's coming theme, and yeah, that's about it. So if you want to have the same extensions as me, go ahead. uh, they definitely help a lot. So, all right. So now let's get started. JavaScript lessons. First one is comments. All right. So how do we do comments in JavaScript? Well, all it is two slashes like this, and now this is a comment. This is a comment, and it will get ignored by the compiler or the JavaScript engine. So I also want to start Quokka on here. So I can press Control Shift P and it will bring up my command palette. Or I can just press Control P and then create a caret. And then that will also give me some commands. And I want to look up Quokka and start on current file. So now it's going to start Quokka on here. I can get rid of that thing that popped up, which is the terminal. But yeah, now this is running. And I can say console log something, and then that will actually show up on the side. I also have that spell checker. That's why it's underlined. So yeah, there's that. We can do single line comments. So this is single line comment, or we can do multi-line comments. And that was with */. And now whatever I put in here is going to be commented out. So, okay, so there's comments. Now we can declare variables in JavaScript. Declaring variables is pretty simple. All you have to do is either do a var in front of a variable, do let, also make sure they're different names, or do const in front of a variable. And there's differences between all these. And I think this is giving me an error because const needs to be initialized. Yeah, so const ones need to be initialized to something. Otherwise, var and let are fine. That's how they are. Uh, there is a difference between these, but I will talk about that later. Uh, when in doubt, use let. Uh, Try and use const wherever possible, but when in doubt, use let. And try not to use var whenever possible. Don't use var. Okay. So let's now assign the value. Wait, no, yeah, store values in variables. All right, so let's do let x equal 10. All right, so now x equals 10. So if I console log x, it will give me 10. So now this value is stored in this variable. All right. We can assign the value of one variable to another. So we can say let y equal x. And then when I console log y, that will be 10 as well. Or I can do x plus 5. And now it'll be 15. We can declare string variables. So here, these are numbers. And types are very important in programming. And here, I can do x dot, and it will give me some methods I can run on this number type. So I can run to fixed, that will like round it. To precision also kind of rounds it. I can, I guess, to exponential, I can do to string to turn it into a string. So now x is actually a string, um, and I can do string methods on it. So these are all the string methods. There's actually quite a few of them. We can do to lowercase to uppercase, although it won't really do anything on a number. But if I do make this a string, then we don't even have to do .toString on it. I can just make it a string like this. It's done with quotes around it. So now this is a string. And now I can just do x dot, and it gives me all the string methods that I can do on it. All right. I can make it like hi there. That's also a string. So I can do x dot, and then I can do length. So what's the length of hi there? I can set that to a variable. So let len equal x dot length. And then we can log length, and it's a length of 8 because there's 8 characters here. 1, 2, 3 with a space, 4, 5, 6, 7, 8. So that's beautiful. Uninitialized variables are just undefined. So if I uninitialize that and then I console log x, it should be undefined. I'll just get rid of that. Yep. So that is undefined. So if a variable does not have a value connected to it, then it's considered undefined. You can also set it to nothing, and that's done with the null keyword. So null is nothing. If it's not defined, then it just wasn't defined earlier in the code. All right, there is camel case. So when we declare variables, we want to use camel case. So we'll say let person with a dog equal I'm a person with a dog. Something like that. So here's a variable, and we use camel case, so that's the first word is lowercase, then every word after that is uppercase. Whoops. So with is uppercase, is uppercase, dog is uppercase. So that's camel case. The differences between var, let, and const, I talked about them a little bit, but basically var gets hoisted to the top, and that is probably very confusing for y'all. But it like doesn't stay in scope, which is really weird. So that's why we don't use it anymore. Use let instead. Let is like var, but it doesn't hoist itself to the top and do unpredictable things. So use let whenever possible. Let instead of var, and then const is also like let. So let const y equal there. We can define x as something else, so we can say x equals what, and then we can say y equals what as well, but it says assignment to constant variable. We get an error because it's a constant, so we can't reassign it. So that's the difference between let and const. Let can be reassigned, and const can't be reassigned. Otherwise, we get an error. All right, so that's that difference. We can do math in JavaScript. So I showed that a little bit as well. So like let x equal 10 plus 5, and that's 15. We can do minus 5 or minus 4. Minus 5 is 5. We can do times 5, which is 50. We can do divided by 5, which is 2. So that's with slash, star, plus minus. We can also do modulus. So modulus is done with the percent sign. And modulus is the remainder of a division. So 10 divided by 5 is 2, but the remainder of that is 0. If we have it be 3, then 10 divided by 3 is 3, but there's a remainder of 1. So then we get 1 for x. All right, so hopefully that makes sense. We can do we can escape characters and strings. Also, I should probably mention, we can do x equals 10, and then we can do x plus plus, and then now x is 11. This will just increment x by 1. It's the same as doing x equals x plus 1. So that's the same thing as that. Or you can do x plus equals 1, and that's also the same thing. Or we can do plus equals 2, and that will be 12 then. But you can't do like plus plus 2 here. It's just plus plus. You can also do minus minus, so that will decrement it. Or you can do minus equals 2 or 1, and that will also decrement it. You can do equals x minus 1, same thing. And then we can also do the same things with multiplication and division. So you can do, although you can't do x times times, you can just do x times equals 10, and that's 100. Or like you could do x divided by equals 10, that's 1 then, or 5, then it's 2. So that also works. Okay, so that's math, and then we can escape characters and strings. So here, let's say, let greeting equal hi, what is up, y'all? All right. So here we have hi, what's up, y'all? Let's say that this is in single quotes, and we have this single quote in here. Well, we still want that to show up, so all we have to do is put a forward slash or a backslash in front of it, and now it will still show up. So if I go greeting here, it says, hi, what is up, y'all? And we need this backslash in here so that it doesn't get confused about where this starts and ends. We can also do that with backslash n. Backslash n would be like a new line, although it doesn't really show up well on console logs. But you do notice that it's like not really showing up. You can do backslash t for a tab, stuff like that. Yeah, but it's not really showing up very well anyway. So, but yeah, that's escaping characters with backslashes. All right, we can do concatenation. So we can say, "Hey, what's up, y'all? Uh, doing well? I don't know, doing well." Do something like that. So now these are connected together, and it just makes one string. Hi, what's up, y'all? Doing well. We can do template literals as well. So we can do $sign braces, but this has to be in backticks. So we have to go backticks, and then we can say, hey, the day is the, and then we can add that number in there. So we can go x 10th. So hey, the day is the 10th because we have this variable x, and it's getting put inside of this $sign braces notation. And now it says, hey, the day is the 10th. All right. And then you can, have more variables in here and then just use $ braces and throw it in there. This is also JavaScript, so you can do very different stuff to it. So you can like say .toString and then .length. So now is the second because this would be a length of 2 because we make it a string and then it's length of 2. All right, so there's that. Yeah, so string length, kind of show that a little bit here. Let's get rid of this. We can do, so strings are kind of like arrays as well, but let's show what arrays are. Arrays are ways to store values, more than one value into one variable. So we can say let x equal uh, 1, 2, 3, 4, 5, and now it equals all those values at once. And then we can find the first, last, and second last values in there. So we can go, say, x of 1, and this is index of 1, so it's actually the second value. Yeah, it's kind of weird. Uh, the starting index is 0, so this is the 0 index, and it's the first number in the array. I know it's kind of weird. So if I do like 4 here, then it's 5. If I do 5, then it's undefined because there's not 6 numbers in here. There's only 5, so it only goes up to 4. I know, very confusing, but it's just the way these languages are built. And this language is similar to many others, and they all do this. So that's that. All right, array destructuring. We can have values in here like hi and hey, and then we can assign those to different variables here by destructuring it as like x and y. So now we can do x, and that's going to equal hi, and we can do console.log y, and that will equal hey. So this value gets put in for x, and hey gets put in for y. Pretty simple, hopefully. All right, we can store values with arrays. Yep, we do. We can have nested arrays, so we can have let part equal some fruits first. So we can do apples, bananas, and then we can surround this in another array. And then for the second array, we can do vegetables. So we can do carrots and broccoli, something like that. And so now the first array is fruits, and the second array in here is vegetables. And then we can grab these values by doing cart of, say, 0 and then 0 again. That will grab the first value, which is apples. Or we can do 1, 0. That will grab carrots because this first one will go through this first value, and then it will go through the second one. And then this second one is more granular, so it will first choose one. So in this case, it's choosing this one over here. And then the 0 index stands for carrots then. And then that's how we get carrots. All right. You can also nest these even further. You know, you can put an array inside of here. You can put array. It doesn't really matter. Although we try and keep them not too nested. Otherwise, it gets really confusing. All right, we can access and modify arrays as well. So here I can do cart of 0, 0. Say we don't want it to be apples anymore. We want it to be oranges. All right, so now when I grab the first one in there, it's oranges instead of apples because we set that value to oranges. All right. We can use push, pop, shift, and unshift as well to modify arrays. So we can say, let's just make this one-dimensional again. Let's just do that. Now it's just a bunch of foods, and also I gotta get rid of that end array. All right, now it's just fruits and vegetables, foods, my bad, foods. And now we can do cart.push, and we can push on another food. Let's say Uh, really feeling the avocados. Avocados. All right. So now when I just console log cart, it's apples, bananas, carrots, broccoli, and avocados. Let's actually make this smaller so you can see that. All right, so yeah, it's actually 3 values in here because we're pushing avocados onto the end of this array. All right, we can also uh, push onto the front. I think that's done with unshift. All right, so unshift will put it into the front. And then we can also take values off of cart by doing pop and shift. So pop doesn't take an argument, it's just like that, and it will pop off the end value of the array. We can also do shift, which will pop off the front of the array. So there it popped off apples. And that actually gets put into a variable if we want to. We can say uh, let f equal this, and then we can say f, and that becomes apples. So the part that gets shifted or popped off becomes this value here, or this variable. All right. We can do functions. So here, let's define a function. Let's go function test. And then here we can run this function by calling it. Although, let's first get rid of some of this stuff. I can get rid of this. All right, let's still use this cart thing in here. So we'll say uh, console.log testing. Actually, let's just do that. Testing, and then we can call this function by doing test, like so. And now it ran that. So you'll notice that without this, it's not running this console log. Oops. Whereas if I have a console log on the outside of a function, console.log testing, this one is running. So here, when it runs the file, it will run this console log no matter what. When it hits this function, it kind of just saves that for later until this test value is called. And we call it by doing test with the braces like this, or the parentheses. And now it's running this console log. And I can do it again and again, and it will then run it again. So here, testing, testing, because we're running this. All right, we can do arrow functions as well. Arrow functions are the same as functions, but they are different, like syntax for it. So we can do arrow functions by doing, say, const test, although we already have that. So let's do test2 equals function like this, equals arrow. And now I can do console.log test2. And now we aren't calling this function yet, but I can call it the same way. I can do test2, call it, and now it's running that console log. All right, so these are functionally equivalent. A lot of people use this syntax nowadays, although this syntax is perfectly fine as well. All right, we can return values from these functions. So here I can actually return testing. And now I can set test to a variable. So I can say let's, I don't know, let's variable, let var equal. No, I can't do let var because they're both keywords then. I can do let variable equal test. And now when I console log variable, console.log variable, it becomes testing, which is what's returned here. If I change this, so high, then this variable becomes high because we're setting this variable to what's ever returned from this function test. Or I can say let variable2 equal test2, and this will be undefined though. So I can do variable2, whoops. There we go. And that's undefined because we aren't returning anything from this function. There's nothing being returned. It's just this console log that's running. We can return a value though. So we can say return null, and now it will be null. We can return a number. We can return a whole host of different things. We can return an array with numbers in it. And whatever I put there in the return statement is going to become this variable of what this gets assigned to. All right. We can have global scope versus local scope. So here we have this let cart equal apples and broccoli up here. I can also do let cart in here equal uh, bananas right here, and then I can return cart here, and then when I console log that, so let me console log CLO, and we'll console log test. All right, so test becomes, let's get rid of this. Test becomes bananas. All right, because this cart up here is outside of the scope of this, and we can just do cart here. But if we just do this without here, now it becomes apples and broccoli. I have to get rid of this shift part. All right, now it becomes apples and broccoli. Also, I should probably not distract you guys here. All right, so we're just running this function test, and then we're returning the cart, which is up here, apples and broccoli, and then that's being console logged right here, apples and broccoli. I can also have local scope stuff, which is inside the function. So you can say let x equal 10, and then I can return x, and now that will be 10. I can also, just have cart here. All right, I can't console log x because x is not defined because it's inside this function, and it can't be used outside the function. But I think if this is var, I might be able to. Oh, nope, never mind. Only with let. But var is kind of weird, so we don't want to use that. All right, so there's x. We can't use it though because it's inside of there, but I can console log test and then it'll be 10. All right. So understanding undefined value returned from function. Yes, we learned that. We can learn Boolean values now. So Boolean values are either true and false. So we can say let is awesome equal true. All right. So now this variable is true. And we can say if is awesome, then return it is awesome. Otherwise, return nope. We can do something like that. And now when we run test, it comes out as it is awesome. If this is false, then it says nope because it checks this if statement and it says, is this true? No, it's false. Well, then just do this else statement, which returns nope, and then that gets console logged here. All right. Also, let me get rid of this white space. Toggle render white space. Yeah, there we go. It was showing those dots, which I probably didn't need. All right. So yeah, Boolean values, we can do if statements, and there's different ways we can do Booleans as well. So we can do false and true, and then is awesome is going to stay as false, as you can see by the nope down here. Or we can do an or, and then it will become true because it's false or true. It will take the true one. So to make my point better, let's say let is adult, or let adult age equal 18. All right, and then we'll say if adult age, or if yeah, we'll say we'll pass in an age here, and then we'll pass in 10, and we'll say if age is greater than adult age, then return is a adult, is an adult, is adult, yeah, adult. Otherwise, return child, is child. All right. So here we're passing in 10, and then we're saying if 10 is greater than 18, then we'll say is adult. Although 18, so it should be greater than or equal to. So if age is 18 now, then it says is adult, all right, which is what we expect. We can also do if age is equal to adult age, then it will be that. Otherwise, it will be if it's 14 or even if it's greater, then it will still be as child because we're only checking equality. And that's done with double equal signs. We can have another condition on here like and age is greater than 0 to make sure it's greater than 0. So we can say -2. And let's say is less than adult age. So age is less than adult age, that would be true, but then age is not greater than 0, and that's false, so then it gets evaluated as false and will be is child. But if this is an or, then it becomes true because age is less than adult age. Uh, but age is greater than 0, but this doesn't even get evaluated because this is already true and this is an or statement. All right, hopefully that makes sense. We can do strict equals versus regular equals. Also, there's a not equal thing as well. So we can say if age is not equal to adult age. So in this case, if we have 18, it will be is child because 18 is equal to adult age, and then it gets returned as false then. Yeah, kind of confusing, but say 15. So 15 is not equal to 18. That's why we return is adult. All right, so this is not equal to. All right, and then there's strict equal versus equals. So we can do equals, and that will be fine even if this is a string. So we'll go 18. Uh, so the string 18 is equal to the number 18, and then it will return is adult. Although if we have strict equal, then it suddenly becomes false. And that's because the string 18 is not strictly equal to the number 18, and then it will return is child. All right. We can return early from functions. So here we're returning, if I have a return statement down here, it becomes grayed out, and that's because we're already returning one of these two possibilities, and you can only return once from a function anyways. All right. Objects. So we can get into objects now. Or actually switch statements. I didn't do those. If statements and switch statements. So we can return this, or we can make this into a switch statement by doing switch. And it's basically the same as ifs. So we can say switch age. We can say age 10, return, no, case, yeah, case 10, return is 10 years. All right, we can do case 18, return adults. All right, and then we can do default or case default, or maybe it's just default. Default, return not 10 or 18. All right, so now when I pass in 10, it will say is 10 years. If I say 18, then it says adult. If I pass in anything other than 10 or 18, then it says not 10 or 18. So this is basically an if statement, except more specific, like with what case this has to be. All right, so this is good for like conciseness if you have specific cases you need to fill. Otherwise, just use if and else if statements because you can chain those together. Instead of just if and else if, you can do if age is less than 5, or yeah, if age is greater than 5, or let's do greater than 18. Then do return adult, and then we can do an else if here, and then age, if age is greater than 15, then do return teenager, teen, right? So in this case, we're passing in 15, but uh, let's do a base case else return not adults 14. All right, so right here, 15 is not greater than 15. It's greater than or equal to, but not greater than. And so then it hits this else statement. If we have like 20 in here, or 120, then it says adult. If we have 17, then it says teen because it's not greater than 18, but it is greater than 15, and then it will return that. All right, so that's how you chain if statements together. All right, now we can get into objects or JSON, which is JavaScript object notation. All right, so let's keep this function alive and let's change this cart into a different type of cart. So here we'll say amount of items of 5, and then we'll say items, and we can have an array for this. So like um, oranges. Actually, let's do amount of items 1, items oranges. All right, so here carts is now set to this object, and if we console log this object, it will be that. All right, and then we can grab data out of here. And this is known as JavaScript object notation. It's a very common way to transfer data around the internet. And we can grab data out of here by just doing cart dot. So cart dot, and then these two keys show up. It's a key value pair, so amount of items is a key. 1 would be the value. We can do amount of items, and now it's 1. Or I can grab items like so, and that will be oranges. I can grab the first item by doing array index of 0, and that becomes just oranges without the array around it. All right. We can add stuff to this cart, so we can go cart dot, and we can make something up. So wheels, cart dot wheels equals 4, and now this cart has a wheels property, and now that will equal 4. Or if I just do the whole cart, then it has wheels 4 at the back. We can also delete properties from this cart. So we do that by doing delete. So delete is a keyword in JavaScript. And we can say delete cart dot amount of items. And now that this property is off of here. So now when we console log cart, it's just items and items oranges and wheels 4. All right. So that's really cool. We can destructure off of this cart as well. So we destructure just with braces. So here we can go amount of items, although we deleted that. So let me get rid of that line. Actually, no, we can't. Oh, because I have to define cart. Yeah, that's right. So actually get rid of that. Uh, Instead, let's do let amount of items and items equal cart. So that's how we grab these two values out of here, and then we can use them here, amount of items. And let's get rid of that as well. All right, so amount of items is 1, and we're grabbing it by destructuring the cart. And we can also grab items. It will be basically oranges because we're destructuring that as well. All right. We can give these different names. So amount of items, we can say a of I, and then we can console log a of I, and that is also just 1 because we're naming amount of items as this variable now. All right, so that's cool. So just in case you need to change the name of the variable. All right, now we need access, adding new properties, deleting properties. We did that. Nested objects, yep, so you can nest them as well. So we can say, I'm gonna make a new object, say let person equal this new object. Let's get rid of this. And let's console log person. Person will say, uh, let's say has a dog or dog. Let's first give him a name. We'll say name Dom, and we'll give him an age of 10. And then we can also give him a dog, but this dog also has a name of buddy, buddy, and a age of 12 or 5, sure. So age, and let's do age of 15 here. Yeah, there we go. So now this person has named Dom, age 15, and a dog named Buddy, that's age 5. And we can grab the dog by doing person.dog, and then we can grab the name of the dog by doing person.dog.name, and that will grab just Buddy. So that's how we can have nested objects. Pretty cool, pretty cool. So if you think of this, it's it can create a lot of data in one object. And let's see if I can. Oh no, I can't. I thought maybe it would format a little bit better, like put these on different lines here. So yeah, so here's dog. Yeah, and a lot of times it'll be formatted something like this. And if I save, then it will stay there. Nice, okay. All right, so nested objects, we can do loops as well. Loops are more for arrays and stuff like that. So, and let's actually use this new way of doing the function. So we'll go const test equal and this. And then we're going to pass in an array into this function uh, like so. And we're just going to do test and then pass in an array of 1, 2, 3, 4, 5, 6. All right. And then we're going to return the array for now. So that will return that off of this function. All right. And then we are going to iterate through an array. Uh, and let's actually make this be words like uh, A, B, and C. All right. And then right here, we're going to actually change the order of it, maybe. So, well, let's actually just loop through an array for now. So we'll do that with a for loop. So for loop, the first value is where it starts at. So let I equal 0. And then the second one is I less than array.length. And the third one is I plus plus. And then I'll explain what this is doing. And then we'll just const log array of I. All right, so that's ABC. All right, so for loops are broken up into 3 parts. This part, the middle part, and the last part. The first part tells us where I is starting. The second part is the condition of uh, when it should keep going. So while I is less than array.length, so in this case, 0 is less than uh, the length, which is 3 at this point. And then the last one is what to increment I by. So in this case, we're incrementing I by 1. We can also do I plus equals 2. And then it will just be AC because we're skipping B because it's incrementing over that. All right, so now it's all 3 again. All right, so that's a for loop. And then we grab each character in the array by doing that bracket notation again. So the first time it goes through this, I is 0. Then the second time it's 1. Then the third time it's 2. And then that will print out ABC in that order. And then we can also, do stuff to this array. So we can have this have a test array in here. And this test array will have like D and E. And say we want this stuff pushed on the end of that, we can just do test array, dot push, and then we can push on array of I. All right, and then it will return test array. All right, and now it's DE ABC because we're pushing on A, B, and C in this for loop, and we're pushing it onto this test array, which already has D and E in it. All right. We can also change this into a while loop. So for loops are good for when you know exactly how many iterations you have to make. While loops are good for when you don't know how many iterations you have to make. So while loops are good for like games. So like we can say while this game is running, or like while this person didn't win, keep going. But for loops are good for iterating through arrays like this when we know the length of it. All right. So we can also make any for loop into a while loop. So we can change this into a while loop, but it has to be structured a little differently, where the condition is the only thing inside of the part here. And then we can say while I is less than array.length, then, keep pushing. And I think it actually just crashed because this loop is a infinite loop. And to make it not infinite, we have to make sure to increment I by 1 every time. And now it will show up again. Because without this, then it will just run this loop forever. Uh, 0 is always going to be less than the array length. And unless we increment I by 1 every time, then it will finally break out of it when this condition becomes false. All right. So that's while loops. And you can also do a do while loop, so that will make it run at least once. And that's done like this, like do, and then while is at the end, like so. And then we can just put the stuff in here. And that's basically a while loop, except do while loop. I have to get rid of that brace. All right. So it'll run this at least once and then check the condition. All right. So pretty similar to while loops, but, you know, slightly different. Just runs it at least once. All right. Next one, count backwards with a loop. So we can count backwards. So we can say let I equal array.length, array.length. And then we can do I minus minus here. And we can have the while be while I is greater than array.length. Then do this loop. So the first time it runs around, I is going to equal 3. So 3 is not greater than array.length. Yeah. Whoops. While is greater than 0. Yeah. All right. So here, yeah, and I have to do I minus 1 here. Otherwise, it'll be undefined. Yeah. All right. So here we're doing this first. So 3 minus 1 is 2. It grabs the last one off here, which is C. So then it will push that on. And then it subtracts by 1. So now it'll be 2. And then 2 minus 1 is 1. It'll grab B. So we're just iterating through it in reverse order this time. And now C, B, and A are back there. And I can also, just make this empty, and then it will basically just reverse the array. So here's a way to reverse an array right here. We can, name this function reverse, and then, whatever we want to reverse, we just put in here in this function, and it's reusable. So if we want, we can, call it again, console.log reverse, and we can reverse a bunch of numbers possibly. So like 1, 2, 3, 4, 5, it will become 5, 4, 3, 2, 1. So there's a way to reverse an array. It's pretty cool. All right, we can iterate through a nested array as well. So let's say we have a nested array in here, and we'll say 1, 2, and 3, and 4, 5, and 6, like here. All right, so we have the outer array has length of 2, and then each inner array has length of 3. Okay, and then we can loop through this stuff by doing 2 for loops. All right, so we're going to go for let I equals 0, I less than array.length, I plus plus. All right, and then we can have another for loop in here of let j equal 0, j less than array of I dot length, because we're grabbing each one of these and then grabbing those lengths then, dot length, and then j plus plus. And then we can, console.log array of I, j. And then that will successfully loop through the entire array. And then we're not returning anything, so that's why this is undefined. If we want to, we can return a flattened array. So we can say let flat equal an empty array, and then inside of here we can do flat.push array of ij, like so. All right, so now that's getting pushed on there, and then all we have to do is return flat here, and then now this multi-dimensional array, it becomes a flat array of 1, 2, 3, 4, 5, 6. All right, so that's pretty cool. All right, so now we are going to go over recursion, and recursion is when you call your function inside of your function. I know it's kind of weird. It's kind of weird. All right, but we're going to do it. So we're going to return reverse, and we're going to pass in the array. But it says maximum call stack size exceeded. Hey, I wonder why that is. Well, that's because we have no base case, and it's just, calling reverse, 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 and it can't break out of this until the stack size exceeded, and we get our computer blows up, and we get a huge error. Uh, so this gets fixed by having a base case and then like manipulating the array every time it gets called. So we can say if array.length is less than or equal to 0, or we can say just equal to 0, then return out, and then we'll say made it out, made it out. All right. And it's still going to have a maximum call size because we're not manipulating the array yet, but we can just manipulate it by doing array.pop. And now it will say made it out. But we can console log the array every time this happens, or we can even like set this to a variable, let popped equal this, and then we can console log that, console.log popped, popped. There we go. And so we can see the first time it goes around, it's 4, 5, 6. Then the second time it's 1, 2, 3. And if I want, I can make this a single dimensional array. You have 1, 2, 3, 4, 5, 6. And now it's actually popping off 6 first because pop takes off the end. So we'll take that one off first, and then 5, 4, 3, 2, 1 until we loop through the whole thing. All right, so that's recursion. It's when you call the function inside the function, returning it at the same time. All right, so now we need random numbers. Random numbers are done with math.random. So let's get rid of this and get rid of that. Return math.random. All right, so now whatever we pass into here, it will just give us a random number, and it will change every time. So if I have multiple of these, you can see all these numbers are different, and that's because it's calling this math.random every time this gets called, and it's going to be a random number between 0 and 1 every time. All right. So math.random is useful for, making games, like maybe choosing a random card out of a deck. So say we have this array of cards here, and we have an array of, say, the Jack of Hearts, so JH, or we have the One of Hearts, One of Hearts, Two of Hearts, and so on. And we want to grab a random card out of here, then we can just grab that by doing cards and then grabbing an index. But this isn't an index right now. It's just a random number between 0 and 1, which is not an index because indexes have to be whole numbers. Well, we can grab the whole number by doing math.floor then, and then every time this gets floored, it's going to be 0. So that's why this is GH. And also I'm going to get rid of these ones. All right, to get rid of that error. That was annoying. All right, so every time this gets called now, it's going to be JH, the first one, because math.floor will always bring a number with a bunch of decimal places down to its whole number. So maybe it will say that, return the greatest integer less than or equal to its numeric argument. All right, so to account for that, we need to multiply math.random by cards.length. So we can do cards.length here, cards.length. All right, so now it will be random every time. So if I have multiple of these, first is JH, then 1H, then 2H a couple times, or if I do it again, then it will run this file again and switch them all up differently. And you can see the usefulness of this. All right, at least I hope you can. All right, so that is math.random, very useful for that sort of stuff. We can parse strings. So right here we have this 1H and 2H in here. So let's actually just pass in one of those. And then we're going to return card. We're just going to return card. Card. All right, so card, obviously we're just returning that, so it'll be 1H. But I can have a plus in front of here, and that will say not a number. I can do parse int, and that will be also not a number, I'm guessing. Actually, parse int will actually take off the number off of the string, and then just return 1. So parse int does that. Let's say this is a string like 1, 2, 3, 4, and we want to make it a number. We can make it a number by just doing a plus in front of it. So now it's a number, and I can do number stuff to it. So like 2 fixed and 2. Let's say this is a dot 1, 2, 3. I guess it's not a function. That's annoying. I guess I do have to do parse float. Parse float for floats. So in this case, parsing 1, 2, 3, 4.123. And then we're doing dot to fixed, which will give us 2 decimal points afterwards. So that even if this is longer, it'll be just 0.12. If I make this 5, then it will give me 5 decimal points. All right, so yeah, parsing strings is pretty important to understand, and like changing those data types. All right, so that's parsing. Ternary operator, that it looks something like this. So we can say if card is greater than 10, then we want to return greater than 10. I don't know, whatever. Otherwise, we can say less than 10. All right, so in this case, this is greater than 10. Let's say 123, that is greater than 10. If I have 1, then it's less than 10. And 5 is also less than 10. I can do 15, that's greater than 10. So it's basically an if statement, except one line. So it's much cleaner and more beautiful. All right? Anytime you can do one-liners like this, you might as well go for it because it makes things a lot easier to read, in my opinion. All right, so we return greater than 10 if card is greater than 10, and we return less than 10 if card is, less than 10, or if this is false. So hopefully that makes sense. All right, we have anonymous functions. Anonymous functions are functions without a name, and they arise inside of different methods. So there's a method called map. So we can say reverse, or we can call this function, and with a bunch of numbers in here, and we'll say array. All right, and then we'll turn array.map. All right, and then this function in here is anonymous, and we'll do a plus 1. Yeah. All right, so it's taking all the numbers in here and adding 1 to them. And so if we go through this array becomes this array. All right, so let me see if I can use this thing. This array gets put in here. All right, then this array gets mapped, and each number of here, each number, let's erase. Yeah, each number. All right, so A first is number 1, and then that becomes 1 plus 1, which is 2. All right, and then that gets stored in like this internal array. All right, and then it goes to 2, and then 2 plus 1 is 3, and that gets pushed onto that internal array until it goes through all of them, and then it will finally return that new array of 2, 3, 4, 5, and 6. All right, so hopefully that made sense. If I do, plus 3, then all of these will be plus 3. There's And then this function in here is an anonymous function because, it doesn't have a name. Like this function has reverse as a name, but this function, it doesn't have one. We can also, if we want to, we can make it have a name. So we can say const add 3 equals this. And then we can actually just click add 3 in here, and that will do the same thing. But if we want to just be inline and cleaner, we just, take this part and throw it in here and then get rid of that add 3 part. And that works the same exact way. All right, so anonymous functions, very useful to understand, and this map function as well. All right, so now we have object-oriented programming with class declaration. This is probably one of the most fundamental parts of programming. So here we have this person, all right, and this person has a name, age, and a dog. We can kind of do the same exact thing, but we can make this person into a class. So we can say class person, and classes are like blueprints. So we're defining what a person is with a class. So what is a person? A person has a name, so we can say name. Yeah, we can give them a name. We can give them an age. We can give them a dog, sure. All right, and then to make this person, all we have to have is a keyword called constructor, right? So, and then how do we construct this person? We need to pass in these arguments. So we're going to pass in name, age, and dog, all right? Although these are different from this, so it can be like it can be named something else, like name one, age one, dog one, whatever. All right, and then we set this dot name equal name one, whatever gets passed in. All right, whoops, name one. All right, so now I'm going to do this for all of these. So in this dot age, and this refers to the current person, which has these properties, right? So we'll go age one, and this dot dog equals dog one. All right. And then when we call this, so we're going to make person now. So we're going to go uh, const Landon, so that's me, equals new person. So now we're constructing a person using this blueprint. And this person takes a name, age, and dog. So name is Landon. All right. Name or age. Age would be 22. I think I'm 22. No, I'm 23. And then a dog. So I can pass in an object, like, and then have my name of dog be Buddy, even though I don't even have a dog named Buddy, whatever. And this dog is, say, 10 years old. All right. So now this Landon person, if I console log him, so console.log Landon, has all these properties in them. All right. And we can actually just grab all these different properties just the same as this object up here. So it's basically the same thing, except uh, it's more definable. Like this is what a person is, and you have to like adhere to that uh, construct. All right, and then we can also add methods to this person. So you can say uh, birthday. So let's say person has a birthday. What happens when they have a birthday? Well, their age goes up by one. So this dot age gets incremented like so. And now when I call uh, birthday on Landon, so I have to go Landon first and then dot birthday and call it. Then my age becomes 24 instead of 23 because I called this function, which actually incremented the age inside of this person by one. All right. So if you think about classes like this as primitives as well, so as a number or a string, so like say this is just a number, so like class of number, then it becomes kind of easy to understand how we get these methods off of like let num equal 10 and then doing num dot, and then we get all these methods. It's kind of like this was a class, at some point, and they just added all these methods in there because I can do, Landon.birthday and then actually call that function, just like, this is a type of person. If it was a type of number, then we can call different kinds of methods, but only the methods that attain to numbers. If it's a string, strings also have different methods on it. So like if this is a string, then we can do, string string dot, and then all these different methods. So it's basically like string was a class or is a class and has all these methods built into it, like dot to lowercase and to uppercase, which will make this string to lowercase or to uppercase. So hopefully that makes sense. It will help you understand what's going on behind the scenes. And I'm getting an error here. I don't know why, but whatever. Let's get rid of this part. All right, and yeah, person is not defined. That's because I renamed this. Yep, person. All right, there we go. All right, so another thing about classes in JavaScript is we can have private private variables. So that's done by adding a hashtag in front of these things. So in this case, we're going to go hashtag name, hashtag age, hashtag. Oh, actually, just so you understand like what this is doing, I can do landon.name and console log that. Or yeah, let me just landon.name, and that will give me Landon. But if I make this a private variable, and then I go this dot name with a hashtag, now the landon.name is undefined because it can't find it. Even if I have hashtag name in here, it gives me an error. It says property name is not accessible outside class person because it has a private identifier. All right, so this is a concept known as encapsulation. It's like no other thing except for this Landon class can access this variable. So if I say, uh, well, what can I do with a name? Like greeting, like, uh, or yeah, greeting. We'll say greeting as a function, and we'll say return hi, my name is, and then we'll add on, concatenate on plus this dot hashtag name. All right, so this is how we're going to get my name. We're going to actually call Landon.greeting. And now it says, hi, my name is Landon, because this is the only uh, portion that can access that name of the person. All right, we can't access it directly unless we use a getter. So getter is done with a get keyword followed by name, like so. And then we can just return this dot hashtag name. And now because we have this get keyword in front of here, that landon.name will work exactly like it was doing before. So landon.name gives me Landon, and that's because we have this getter in here. If I didn't have this get keyword here, then it has to be called as a function, and now it will give me Landon. All right, so hopefully that makes sense. Private variables, very useful to know about. All right, next thing is functional programming. So functional programming is kind of confusing. So let me get rid of this class first. Or do you guys like this class? I kind of like this class person. It's kind of cool. Yeah, but let's start new quick and create some functions. We call this, we have to do test x or pass in, 10, and then we can call it again with 4, and then it gives us 14. So when we call this the first time, test 10, it returns a function, which then we have to call again, but this time pass in 4. So the first time this runs, 10 becomes x, but now this is stored internally, basically, inside of this. And then when we call it again with 4, then it will run this function right here, and 4 becomes y, and then it will finally add up 10 plus 4 into 14. All right, so that's functional programming. We can also go one step further, and we can say this function returns z, equals z, or x plus y plus z, x plus y plus z. And then we can put another thing in here of 5. So now it's 10 plus 4 plus 5 is 19. And, this could be called add or test, whatever. But yeah, so that's functional programming for you. A little bit confusing, I know, but it is a concept worth exploring. All right. Importing and exporting code out of uh, files. So we can export this with export const. It's done with this export keyword in front. And then we can import code by doing import. Although import is probably not supported for Node.js. So yeah, just be aware of that. And it's kind of hard for me to show what this does, but I can import some data. Actually, I think I can import data from, and I can say like /data.js. All right, so if I go to my files and I make a new file called data.js, I can say export const data equals some data here. So key value. All right, and then I save that. And then I go into index.js, and this data variable is this data here. All right, and then I think I can use it. I think I can console log it. Let's try it. So console.log data. And I think that will become that. And I can run this file by opening up my terminal, going to terminal, and then running node index.js. And it actually gives me an error. Cannot use import statement outside of module. Yeah, kind of thought I would get that error. Let's actually try require equals require. So this is the old way of doing it. Require ./data.js. And then let's try running this again. I still get the same thing. Darn it. Data is not defined. Yeah. Even though I have data there, maybe I have to save. Maybe I had to save, yeah. Ah, darn it. Same thing. Warning to load it. Yeah, okay. But that's just, you gotta trust me, that's how you do it. You either do require, or the new way of doing it is doing imports. Like so, import data from. And that's how you move functions and data around different files. One last concept to go over is promises. So promises is when we need data from an external resource, like an API, and it takes time for it to fetch that. So it's basically noted by an async function. So we can go async. And now this function could take a lot of time to run. And we can say like const fetch or data or response equals await, and then our fetch function. So fetch, await fetch, and then return response.json. And now whatever we fetch, so say we fetch from a external website like https://google.com / whatever or whatever like that. It will fetch this resource, but it takes time for it to fetch it, and that's why it's async and await, because it takes time for this function to run. And then while that's happening, we can do other stuff. So it's done with async await. We went through a bunch of stuff today. We went through comments, how to declare variables, how to store variables, assign value of one variable to another, declare string variables, what uninitialized variables look like, which is undefined. Camel case, we can define differences between var, let, and const. We can do math in JavaScript, escape characters and strings, concatenation, find a string length. We can do bracket notation to find the first, last, and second to last values in an array. We can do array destructuring. We can store values with arrays. We can do nested arrays. We can access and modify data with indexes. We can manipulate arrays with push, pop, shift, and unshift. Functions, we learned about those, arrow functions as well, global scope versus local scope. We can understand undefined value returned from a function. Boolean values, we can do if statements and switch statements. We know what greater than, less than, equal, not equal, strict equal. We can do logical and, logical ors. We can return early from functions. We know what objects are, which is JavaScript object notation. We can access those properties and destructure them. We can delete properties. We can nest objects. We can do while and for loops and do while loops. We can count backwards from a loop to like reverse an array. We can iterate through an array, iterate through nested arrays. We can do recursion, which is calling a function in itself. We can do random numbers, we can parse strings, we can do ternary operators, which is like an if statement. We can do anonymous functions. We can do object-oriented programming, which is very useful to know. I want to highlight that and emphasize that learning object-oriented programming is probably one of the biggest things you can do for programming in general. Functional programming we did a little bit of, and learned how to import and export code, and as well as promises, which is denoted with the async await portion of code. All right, if you liked the video, make sure to give the video a like. If you like this format, make sure to let me know. If you learned a lot, make sure to tell me what you learned down in the comments. And without further ado, I will see you later. Peace out. Bye.